Good afternoon, ladies and gentlemen. Good evening, South Asian friends, and good morning to our European friends. I welcome you all for today's e-conference on green chemistry and sustainability, challenges and opportunities, organized by Indian Chemical News. Indian Chemical News is a new age media platform which provides a complete 360-degree view on the chemical vertical, both local as well as global. ICN portal focuses on chemical, petrochemical, oil and gas, pharmaceutical through news, views, trends, analysis, technology updates, interviews, and columns. Indian Chemical News disseminates information to chemical industry stakeholders through multiple platforms, news portal, research reports, e-conferences, industry reports, and others. Myself, Praveen Prashant, editor Indian Chemical News, will be your host and moderator for today's e-conference. The topic for today's e-conference is green chemistry and sustainability, challenges and opportunities. Green chemistry aims to reduce chemical-related impact on human health and virtually eliminate contamination of the environment through sustainable prevention measures. Now, let me introduce you to our speakers. The next slide, please. Mr. S. Sunil Kumar, President, Henkel India. He is responsible for steering the company through its next phase of growth. He is also Regional Business Director, Packaging SBU for India, Middle East, and Africa for Henkel Adhesive Technologies. Next is Mr. Vinod Parimal. He is the Regional President of the Indian Subcontinent Evonik. Within few days, he would be completing his first year as a Regional President of Evonik. He took over the position of Regional President from July 1st, 2020. He has 17 years of experience in successfully leading marketing, strategic projects, sales and production teams across Germany, Singapore, UAE, and the UK. In India, Evonik has 3 production sites, 2 R&D centers, and 7 application technology labs in and around Bombay. Our next speaker is Mr. Maulik Mehta, CEO and Executive Director, Deepak Nitrite Limited. He is responsible for the growth momentum as the company enters the 50th year of operation. He has around 12 years of experience in business development, strategy, human resource, patent, product development, and external relation with increasing responsibilities. Next speaker is Dr. Kamlesh Pai Fondekar. He is the Head Research and Development, Godrej Agrovet Limited. He has over 30 years of academic and techno-commercial experience in chemical research, process development, formulation development, and technical services within agro, pharma, specialty, and oil and gas chemicals industries. He has filed 4 international patents, published 17 scientific papers in international journals, and 1 book chapter. Our next speaker is Dr. Pramod Kumbhar. He is the President and CTO of Praj Industries Limited. After working for 20 plus years in the petrochemical industry, he made a shift to biotechnology-led renewable fuels and chemical industry, and is presently focused on driving innovation in industrial biotechnology to make biofuels and biochemicals. In 2020, he got the UAA ICT Distinguished Alumnus Award from UD Alumni Association and ICT Bombay. He has 30 plus international patents and more than 25 publications in peer-reviewed scientific journals. Our next speaker is Mr. Mirik R. Gogri. He is the Head Corporate Strategy, Aarti Industries Limited. He has a proven experience in corporate strategy, sustainable technologies, and commercialized execution. Fueled by the idea of innovation and research, Gogri is spearheading the setting up of a world-class research and development center with expertise of 300 scientists and engineers driven by a roadmap which will propel Aarti Industries' growth in future. Gogri is working with companies and organizations across the world to find solutions for global climate change goals. Next slide. The key discussion points, we have a number of them, and we will try to, what we can say, touch all these during the course of this discussion. Green chemical processes and applications, green chemistry and technology, green separation techniques, waste management and recycling, energy and water conservation, waste reduction, climate change mitigation, carbon dioxide capture, storage and utilization, energy storage and network, green solvents for energy conversion, biofuels and bioenergy, cleaner production and green nanotechnologies, future challenges in green chemistry engineering, and hydrogen energy and fuel cells. Next slide. Just a few of the e-conferences that we are doing in the month of July and August. We are focusing on July 23rd, draft PCPIR policy, making India a petrochem manufacturing hub, and on August 6th on agrochemicals, doubling the market size by expanding horizons by 2026. Next slide. Thank you, and for speaker and content participation for e-conferences and for participation on our website, please connect with me at praveen@indianchemicalnews.com. Mobile number is 9899004608. And for branding opportunities, you can connect with my colleague Yogesh Joshi at yogesh@indianchemicalnews.com. And his mobile number is 9811431195. So with this, now let me open the panel discussion. All panelists will get 3 tracks of 3 minutes each. And once we are over with the panel discussion, we will open it up for Q&A. So delegates, keep typing your questions whenever you feel so that we can take it up after the panel discussion is over. So let me now call my first speaker, Mr. S. Sunil Kumar, President Henkel India. And so I would request him if he can focus on how does Henkel India collaborate with its customers to develop sustainable products using green chemistry and examples of such products the company has developed. So over to Mr. S. Sunil Kumar, President Henkel India.
Thank you very much, Mr. Praveen, and also to my fellow panelists who have joined me today. Pleasure, speaking today in this forum, and also warm welcome to all the participants who have joined this e-forum this afternoon. So before I start, first and foremost, before going to the customer part of things, let me start with our what is our strategic purpose at Henkel, and globally, how do we look at this whole subject from an angle of overall strategy. At Henkel Global, we have the strategy which basically underpins in 5 pillars. The first of them is pretty much around how do we bring a competitive edge to our own customers and bring the necessary differentiation around it. And the 3 key bits there are with respect to innovation and then sustainability, and how are we going to sort of look into competitive models to make it happen. The main thing in this is obviously sustainability, which is also today's topic. And at Henkel, the first thing is we take all of our members to be sustainability ambassadors. So we are around 56,000 members, and all of them are very much focused as sustainability ambassadors. The other 2 pillars are pretty much around, how are we really looking into clean models, future models, and how do we make a difference internally and externally from that perspective, and all of them underpinned with very strong leadership and collaborative culture. So I will kind of focus first on how are we talking with our own customers and how are we jointly making a difference. Today's sustainability is a very common theme all of us are focused on, and rightfully so, because the planet that all of us are living needs a collective end-to-end support on this topic. And I know each one of us have been endeavoring on it in multiple areas, but some examples to talk about from our perspective. The first and foremost is there are many products which over a period of time, and have been used. And let me take a technology like maybe a toluene technology, which was being used in many of the industries. So we have worked very closely with the industry, and I must give credit to the industry also, because I don't think all alone one would be able to do it. And we have come out and introduced completely toluene free products, and that has really helped from an health and safety perspective for the people that we talk about. The second thing, which as an example, if I had to talk about, is when we talk about, let's say, in the area of automotive industry, where everybody is focused on emissions reduction, and one of that link is very much around lightweighting of vehicles. So here we have worked very closely with the automotive OEMs and the component manufacturers to see how we can jointly make this difference and bring certain technologies which will help in overall weight reduction at the end of the day. The other one in a very different field, if I had to sort of take an example, would be is today all of us are focused on plastic waste management, and that is an important topic, with regards how are we reducing plastics, or how are we responsibly using also plastics. So in this area, we have developed technologies in the adhesives part of the area, where we have changed from what all of us are very much used to, what I call as let's say plastic straws, right, which was very common in use. And we have been now able to come out with working on paper, and a very differentiated set of paper with set of coatings, and that can work on very low temperature fluids or liquids, and also on high temperature. And with that, we have moved completely, from a plastic to a paper point of industry as such. I'll leave a last example before I take a pause and stop. Is also, we have worked very closely in the same area of plastics, where we use certain technologies of hot melt adhesives, as we call, which has completely replaced, shrink films, which was being used in the packaging industry to hold on to materials or cartons, or even to do the overall packaging after the whole secondary packaging has been done. And we have been able to change it using hot melt adhesives, so that that is helping in tamper proof closures and things like that. So some of the examples from our side as to how we have been working with our customers to overall reduce and help them together, rather, on the sustainability agenda. Praveen, thank you very much, and back to you.
Sunil, is you talked about the automotive part, you talked about the plastic waste, and you also talked about the packaging industry. In terms of green chemistry and sustainability, how what percentage would have been attributed from these small experiments that you would have done with these verticals moving forward? So any numbers or any?
Right, sure. See, I mean, let me take it a little more, I mean, maybe broader and higher. I mean, in the sense, what we, measure, I mean, at Henkel is basically from a sustainability point of view, we call it as, you have to enhance more value and on a reduced footprint. I think that is the broader theme. But that said, I mean, let me quantify it with certain metrics, which I think will make it, even more clear and meaningful. We have taken, very clearly three big metrics first to start with, which is around how do you reduce the energy, how do you reduce waste, and how do you reduce on the water consumption. And we started this journey, and with a very clear focus from the year 2010, saying that every year on each of these metrics, we want to reduce at the rate of 3% year on year on all the three values. That means 3% across waste, water, and energy. And we are pleased to report that post 10 years, that is, we also made an assessment as of year 2020 against the targets of 30% that we should have achieved on an overall basis. We have been able to achieve 44% in the case of waste, and also in the case of energy reduction. And in the case of water, we have been able to do 28%. On an overall basis, we have achieved close to 39% reduction in the last 10 years period. So that is the way I would like to quantify this, because that is what we measure literally month on month and across the organization and across all the plants from what we produce per ton.
Thank you, sir. I will come back to you. Now I come to Mr. Vinod Parimal, Regional President of the Indian Subcontinent, Evonik. Sir, I would request you if you can talk about the membrane technology and its implication in green solutions for green separation techniques. So over to Mr. Vinod Parimal, Regional President of the Indian Subcontinent, Evonik.
Thank you, Praveen, and yeah, thanks also to the colleagues on the panel, right? Respected colleagues, yeah, it's an honor to be with you. Maybe I speak about a little about what Praveen said and what is the background of this. The background of this is really driven by some of the requirements that India has in terms of using sustainable alternatives for transportation, right? In terms of what kind of fuel could be used and how to deliver, what kind of technologies we could support to deliver that kind of fuel. I'm talking specifically about the Satat initiative that the government of India has. Satat is sustainable alternative towards affordable transportation, right? So this promotes compressed biogas, right? And this is, compressed biogas as an alternative, let's say, green transport fuel for India. Right. The target of the initiative is to set up about 5,000 compressed biogas plants set up by investors over the next 3 to 4 years, with a target of about 15 million metric tons annually being produced. So this is also in line with the Atmanirbhar scheme, or let's say the Atmanirbhar Bharat goal, the Swachh Bharat mission, and we try to support it with something called the Sepuran membrane technology. It's called Sepuran Green, right? Turning organic waste into green energy source. That's basically, in a summary, what we would like to do or we would like to deliver. So the membranes are polyimide membranes, hollow fiber. They are produced by Evonik, right? And we are backward integrated into the polyimide technology, let's say the polyimide chemistry. Biogas is produced by fermenting biomass, right? And the sources of that are several. There is liquid manure, industrial waste, sewage sludge, renewable raw materials such as bio waste, which would have been burnt, agricultural bio waste, for example, right? The Sepuran membrane, let's say, upgrades the biogas produced and converts it, let's say, into a very pure methane, right? So separates out the carbon dioxide, so and then delivers it directly to the gas grid, right, without any additional chemicals or water being used. So really a green solution from that perspective as well. So the use of, let's say, industrial waste, of agricultural waste, without use of chemicals, additional chemicals or water, to deliver, let's say, an alternative, let's say, fuel, a green fuel, right? As we understand, by compressed biogas, it emits up to less than 80% less carbon dioxide than conventional diesel engines, releases 99% less dust particles, nitrogen oxide emissions reduced by about 90%, noise reduction by about 50%. So there are a lot of environmental benefits by switching into compressed biogas, right? And this is what this membrane technology supports, right? In a nutshell, this is what we aim to do, and also to support the government initiative.
So you said 5,000 CBG plants. So in India, or is it?
Yes, in India. So globally, there are already 600 plants already set up with this technology. So hopefully there will be more among the 5,000 using that technology as well. I mean, there are other technologies, of course, right? So we support it, and then we say that we use less or no chemicals, no water. But of course, this is a tried and tested method, right? Compressed biogas. So there are plants around the world already.
And by
the
what
government plan in India was 5,000.
And by what time frame are you looking at?
So the government plans to establish those plants within 2025. So that's the time frame that then we would aim as well.
Thank you, Vinod. We will come back to you with the second round of question.
Thank you.
Before I bring Maulik Mehta, CEO and Executive Director, Deepak Nitrite, let me run a short video of Deepak Group. So I would request my colleague to run the video, please. Thank you. The message in this video is very clear. It talks about plantation drive in Nanseri, Dahej, Taloja, Hyderabad. And then the focus is on clean air, clean water, preventing soil contamination and digital economy. And the message is efficient management of natural capital is integral to the business and operations. So with this in view, I come to Maulik Mehta ji. Sir, how are you striking a balance between productivity and sustainability? And what are the technologies for sustainable manufacturing? So over to Mr. Maulik Mehta.
Yeah. Hi, good afternoon, and good afternoon to all the panelists and also to the event. So as a company, as Deepak Group, we have been investing in sustainable manufacturing since our inception. Our tagline actually is responsible chemistry, and what we imply by that is a sense of responsibility, not just towards the environment, but towards all of our key stakeholders, our employees, our customers, our investors, and the society, the proletariat around, the community at large. And whether it is through the Deepak Group or the Deepak Foundation, which is associated to, we have ensured that on all of these key stakeholder pillars, we have worked relentlessly. And in most of the cases, we have done exceedingly well. There have been very, very good opportunities for us to learn. I think what is the best for responsible companies is, of course, to talk about what good they do and what great initiatives they have taken up. But the right thing to do as responsible citizens and corporates in India is also to share learnings where things have gone well, where things could have been better, and what we can do together as a community in order to ensure that we meet and exceed future targets. Because if we spend these opportunities extolling the great things that we have done, then we leave a lot on the plate in terms of how we can actually collaborate together, share our learnings with each other. Now, with regards to the Deepak Group, I'm very, very happy to say that every one of our employees, whether it is on the shop floor, whether it is the plant heads, whether it is the corporate team, all of us do subscribe really, truly to the triple bottom line concept of the 3 Ps. And we take people, planet, and prosperity or profitability, whichever way you want to look at it, we take it in that order. We have been accredited with Responsible Care, Together for Sustainability. We're part of that initiative. We're part of the Nicer Globe initiative. We have taken various actions at many of our plants to recognize that our responsibility doesn't end at the gates of our factories, but it goes far beyond that. We take responsibility in the way that our material is transported, handled even at our consumer ends, whether it is aspects of ensuring that during COVID, during periods where there is a limitation in terms of manpower at various plants, at our customers' ends, at our suppliers' ends, we ensure that whether it is sustainability or it is safety, none of these things are negatively impacted. So at the end of the day, a chemical company's responsibility goes far beyond the ambit of its own walls. And moving forward, I think that the society at large will recognize the value of a chemical company only when it recognizes the responsibility that it takes end to end. Otherwise, at the end of the day, what we hear all the time is that the chemical industry is society's favorite scapegoat. It's very difficult for most people who are consumers to recognize the impact and the value of the chemical industry. And I think that it is our joint responsibility to ensure that this happens. Just, I'll take a minute also to share what we have done in Deepak. All of our plants are certified with ISO 9001, 14001, 45001. All of them have occupational health centers. They have all migrated to the ISO 14001 2015 standard. In just the last year, we have reduced our emissions by more than 115 lakh tons. Our treatment and recycling facilities have led to conserving of more than 2 lakh kilos of kiloliters of water. In the last few months, we have commissioned 4 new biological treatment plants across all of our locations. Our phenol and acetone plant, an IPA plant, it is the lowest thermal and water footprint plant of its kind anywhere in the world. And we started off with a challenge. We did not have enough land, we did not have enough money, but we had high ambition. So we needed to see what we could do to be able to manufacture more than 2 lakh tons of phenol and acetone a year. We had to do this in a space of about 30-35 acres. And our goal was never to limit ourselves at 100% capacity. We've been running at about 120% capacity for the better part of the last year consistently. And that means that at any given time, there's about 4 lakh tons, 4 to 5 lakh tons every day that go in and out of a plant which is 35 acres. This is a challenge, and it can be significantly more of a challenge during periods of duress, like what we had with COVID. So what we have done in those cases, coming to technology, is we have enabled, the entire plant is IoT enabled. We have a low frequency network of sensors spread across the plant. Every truck driver who comes in has a very clear path about where they have to go. So we have either trucks that come in empty and leave full, or trucks that come in full and leave empty, or trucks that come in full and leave full. Now, ensuring that this movement, ensuring that safety is of paramount concern, ensuring that the right truck goes to the right location and it does so without disruption is a mammoth task. Doing this in a way which is ensuring efficiency and productivity. Without this, we would not be able to run this plant. We have storage for maybe about 5 days of raw materials or finished product. And that is the only way that we have been able to do this is by leveraging a technology which at least the Deepak Group was not known for only a few years ago.
So I think you gave a lot of data, sir. I just wanted to know how do you keep on raising your bar year after year?
I think two things that we have done is one, in the last 5 years, we did a lot of navel gazing. We decided that the right way to grow is for us to be able to be much better at self-reflection, be more self-aware, acknowledge what we have done, which has worked, acknowledge what we have done that needs to work better. There are a lot of places where we realize that the intention and the outcome were quite different from each other. We put in a lot of high-tech assets, thinking that yes, this is the right way, this is the future. We have to focus on sustainability. Let's get some of the best equipment worldwide. We were not able to run it as effectively as we should have. We needed to do a lot more teaching and training, whether it is contract employees or even our own equipment that that sounds very fancy, that is that is engineered in places like Europe or the US or Japan, very often is not suited very easily to Indian conditions. And so we had to ensure that these are learnings that we took. We recognize ourselves that we're not as good as we need to be, or what we're expecting out of it. Worked on that. We have taken an initiative over the last 3 years to say that in the chemical company, there should not be anything such as waste. Right? Waste is a word that we attach when we think of it as a necessary nuisance. It is something that is almost swept under the carpet in order for us to produce what we want to produce. So we first of all taken a position that we will not look at manufacturing anything which has yields of less than 70–75%. That means that we forego a lot of very good opportunities which might result in 40–45% of our reaction going to waste. So we have ensured that in the effort to create steps towards a circular economy, we've identified all of these aspects, and in treating them a little bit more and purifying them, perhaps in some cases managing the particle size distribution, we have done we've taken a first few very good steps towards actually having in some cases a tail that wags a dog. And so our goal over a period of time is to ask ourselves why something should be considered waste. It might be a waste for our current target market, but is it a waste for another target market? Can we not conceive of how it could be valuable? And finally, the last thing that we did in order to elevate ourselves across the group, not just in a particular location, was to do a much better job of documentation of the learnings, improving the opportunities for cross-functional teams to be created, cross-fertilizing of ideas to ensure that if something has not worked in one location, it is not just that location that tries to address the problem, or the corporate support team that tries to. It is an all hands on deck situation. And what I can tell you is that I personally have really not contributed much to this other than facilitating the passion, the commitment, and the competency that is already there. And I think that it will be there in most good companies in India. So in my case, all that I have done is give it the opportunity to self-propagate.
Thanks, Maulik. Good to know that you are documenting everything and the learnings are being shared across different plants. And one more thing which has come out is the smart factory concepts that you are working on. These definitely will go a long way in terms of efficiency and productivity as we move forward. Thank you. We will come back to you. Our next speaker is Dr. Kamlesh Pai, Fondekar, Head Research and Development, Godrej Agrovet Limited. And my question to him would be, what are the challenges in terms of implementation process and application? So if you can talk about these, sir. So over to Dr. Kamlesh Pai, Fondekar.
Yeah. Thank you. Thanks, Praveen. And good afternoon, everybody. Good afternoon, my fellow panelists and all the listeners. All right. Thanks for this opportunity to talk about participate in this green chemistry. Yeah. So, yeah, you are right. From the terms of the implementation processes in application, it's a really challenge because today, green chemistry implementation is more or less based on the economic value rather than the sustainability, right? Because if you really see in our Indian chemical industry, out of 12 principles of green chemistry, very few are practiced today. Like typically, we have a lot of solvent recoveries, yeah, so it is very good part. And we also have an intrinsically safe processes because this will also avoid all the accidents. But again, we are yet to touch a lot of atom economy, other things which we really take care, but we are really yet to touch all the 12 principles or maximum principles out of it because there are challenges and that's something which we are looking at. In my perspective, only green chemistry is not good enough for a process for commercialization. This is a reality, right? And economic and technical challenges very often hinder the commercialization of chemical processes. Today, green technology involves knowledge of even green engineering. And if you see generally, the chemists, when they develop the process, they lack the training of engineering, which further obstruct the implementation of green chemistry on the industrial scale. Yeah, that's one other big challenge. Again, green chemistry doesn't come cheap, right? So capital investment is also rather a reason we do not work in favor of a commercialization of green technology. It's not easy. And most importantly, even if after you take care of all these challenges, again, green processes may not be very successful if it is not economically viable. And therefore, the green technology, whatever we develop, must compete with the classical processes with respect to the cost of the product, right? And if you really see over the last few years, the commercialization of very few green technologies across, right, globally as well. People have used the ionic liquids, supercritical carbon dioxide as a solvents. But again, it did not get the success what was really expected out of this technology. If you look at the microwave chemistry, which is also very green, very popular with academia, but we are still yet to see the success in the commercial application. I was very happy to read actually the recent articles from the US where people started using the surfactant mediated coupling reactions, which is a micelle type reaction, which is very green, but again with a limited number of technologies really coming in. But I am completely optimistic, right? Going forward, in my opinion, a flow chemistry, which is a really green, will really get a very good traction. That's what I strongly believe in. Yeah. And the next few years, because we really feel that flow chemistry will give a tremendous opportunities. And very, very likely, I know a lot of technologies are being really looked at a commercial level. Quite a few of them are commercialized, and this will really take a new shape for the near future. That's what I look at. Yeah? And therefore, the continuous processes using flow chemistry will be the key for our future.
Sir, one short, yeah, please go ahead.
Yeah, and also basically, if you really see, I envisage the regulators will drive the change in green technology going forward. We have seen Europe really getting into the REACH regulation, which made to take a lot of toxic things under control, and they have really taken care of certain things to a certain extent. But I think in India as well, I think in my opinion, the regulators will also drive this technology considering the overall situation.
Sir, so you said that only few technologies or few green chemistry principles are being followed.
Correct.
So what is, so when do we see the remaining being followed, sir?
I think this is something which, because again, when the commercialization becomes much economically viable, right? So for example, when I talk about the flow chemistry, we really see a good benefit, good quality product coming out with a much better cost control. Your safety is taken care, your continuous processes. These are the technologies what we are looking at, where our cost of the product will be highly competitive to the classical processes what we use today. Yeah, and that's where we will really drive the innovation and drive the technology of the green chemistry.
So you want to say that it will be all driven from research and development, which will happen in a big way so that the cost will come down and finally will get adopted by industry.
Absolutely. Unless it's an economically viable process, I think will be very, very difficult for industry to move in that direction. And the newer technologies only can bring this change.
Thank you, sir. I think you simplified this complex subject, and this is what say learned people like doctors try to oversimplify things and make it easy for everybody to understand. And I think our delegates will also love the concept that you talked about with respect to microwave, surfactant flow chemistry, green engineering, green chemistry, economical. So all these terminologies were very easy for me to understand about the green chemistry per se as such. Thank you, sir. Now I request Dr. Pramod Khumbar, President and CTO Praj Industries Limited, if he can talk about the role of renewable fuels and chemicals in the context of green chemistry. I would request my administrator, Saurabh, if he can share the screen for Mr. Pramod Khumbarji, so that he can show some slides. So over to Mr. Pramod, Dr. Pramod Khumbar.
Good afternoon all, and thanks Mr. Praveen for giving this opportunity to talk at this forum. I will share some slides basically that I had prepared earlier for one of the conference, but that are very apt to this session. Can you see this?
Yes, sir, we can see your screen.
Can you see the full screen or?
It's visible, sir.
Can you see the full screen?
Yes, sir.
Okay. So this is what we talk about when we talk about green chemistry or sustainability, is mostly about the global climate change. And if you see the 2020 report of WMO, 2020 was one of the warmest years. And the global average temperature about 1.2 degrees Celsius above the pre-industrial areas. And the 2011-20 decade was one of the warmest. So the climate change indicators and impacts worsened into 2020. So this is very important to take this sustainability or green chemistry when we talk about, it's very important. So at Praj, what we are doing is there are two platforms that we have been working on, biomobility and another is the bio. I will talk in some details. Just to give a background about Praj, and there are some figures which are very relevant to the sustainability. 8 glorious years in Praj. One of the important things is 8% of global ethanol production comes from Praj plants. Is 350 plants across globe. And one of the indicators of our green technologies or savings of carbon dioxide, about 7.4 million metric tons of CO2 per annum is saved through Praj technologies across the globe. Of course, we have other indicators of 300 plus patents. Those are important. We are also being recognized by Biofuels Digest, which is a globally most respected journal, as #1 company to work for in bioeconomy, #2 in renewable fuels and chemicals, and #3 in engineering partners. And Dr. Chaudhary has been recognized by Bio Iowa, which is the biggest award in biotechnology, industrial biotechnology last year, by George Washington Carver Award. The R&D center where we do most of our technology work is about technologists working in this field. We are one of the best facilities for doing industrial biotech, biology, chemistry, and engineering. Of course, we are dedicated to advancing biology and green chemistries. So the focus which is apt to this, what we are talking about, is renewable feedstock. We talk about mostly carbohydrate. Green technologies, or renewable called fuels, chemicals. Biomobility platform has been last 38 years. We are building plans to make ethanol, which goes as a blend to biofuel. First generation and second generation ethanol. The first generation starts from the feedstocks, which are directly sugars like sugar. Second generation is converting biomass to ethanol, which is the residual biomass that comes from is the biomass residue like paddy straw or wheat straw. So we are one of the competitive technologies globally is called Infinity. We launched this technology 2 years back. We put a demo plant and we are currently building 3 commercial scale plants for oil marketing companies in India on this technology. Last year, we collaborated with CCAB, a company in Nordic countries, to convert forest residue to ethanol. It's a combined platform called Salinity. This is mostly for the European countries. Will be building these forest residue-based ethanol plants. We are working on marine biofuels. Basically, there is a regulation that is coming up for low sulfur marine biofuels. The marine sector or the shipping sector has been using the residues that come out of the refineries, which is high in sulfur. We have a technology which uses very low sulfur marine biofuel from lignin that comes out of our biomass ethanol plants. We are working on sustainable aviation fuels, which is very important because of the new regulations that are coming up. We have collaborated with the company in Geo for converting sugar to bioisobutanol and jet fuel. We are also working on sugar to 2,3-butanediol and SAF. Renewable natural gas, we are very strong in this area. 2 years back, we launched this program based on the SATAT that one of the panelists talked about, the SATAT program of Government of India. We have built biomass to biogas demonstration plant at Praj Matrix R&D Center. We are executing a project for HPCL, one of the first projects which will go on stream based on rice straw to biogas. Of course, we are building plants for sugar residues to biogas, which is called rain gas. And we have our own technology for biodiesel, which is an enzymatic biodiesel technology from oils. But as you know, one of the biggest issue in the biodiesel technology is availability of feedstock. But this is an enzymatic technology, which is very green technology. So just to take you to the mobility to bioprism, this is the program we launched last year for renewable chemicals and materials. These are some of the work that we did earlier on the converting these sugars to different platforms. The most important is the technology to make all from C5 sugars that come from the biomass. Technology which was patented across globe, number of that IP to an European. These are the technologies that we already worked on for last 7-8 years. New technologies that we are looking at basically on the plastics. And we say that the plastic is the most stable, but the problem is not. We are looking at chemicals and materials from low carbon intensity. Focus is basically we are working on bioethylene glycol to ethylene glycol, monoethylene glycol, not to go by ethylene, iobutadiene, and of course the part that we are working on. There are 2 plastics that we are working on starting from renewable resources, is the PLA and PHA, which get this commercialized by 2. One of the things from this figure is people forget that what is really a biodegradable plastic or bioplastic. So you have to focus on the right hand corner, top corner, which is both renewable resources and biodegradable. That's what we want to get into. So this is what we talk about Praj as an enabler for renewable industry, including biofuels and
Thank you, sir, for a complete overview of the technology and the solutions that you are working. with different partners in different parts of the world. Now I come to Mr. Mirik Gogri. He's the head corporate strategy, Aarti Industries Limited. And my question to him would be, how is Aarti looking at green chemistry and green technologies? And what are the opportunities for the industry in green transition? So over to Mr. Mirik Gogri.
Yeah. So good afternoon, and this is my first occasion in such a panel. So it's really appreciate the space given to me, and good afternoon to everyone attending the conference. So I think there are two aspects, as you mentioned. One is the green chemistry aspect. So there, as Dr. Kamlesh so nicely put, that a lot of green chemistry is circled around economy, right? That the atom economy is there, where you want to increase the yield, reduce the waste resources, and it's all economic linked. So if you do better in that green chemistry, then you naturally have a distinct economic advantage. So over the past years, Aarti, because we have a lot of energy intensive processes, specifically around separation processes. So the resource utilization for energy is very much important in our scheme. And that is what our focus has been. Simultaneously, the yield side of things. So how do you ensure that the yields are continuously improved? And I think Mr. Maulik also hinted on that how do you choose your products? That's an important element that we also take up at a very early stage in our R&D itself. So at the R&D stage also, there is a definite targets of certain yields that if they are achieved, then you take it forward. And one more thing that we have envisaged is sometimes the R&D may say, okay, this is good, but then the engineering people down the line may say, no, there are some problems. So how do you ensure that the engineers come up at the beginning itself, so that we do not want to just do R&D for the sake of, say, literature publication. We want to ensure that it's successfully commercialized. So those are a few of the things that we do on the green chemistry side. One more important aspect was the flow reactor. So we have sort of invested a lot in this technology. Some of the, at a small scale, we have also commercialized a few reactions. We have a well-functioning flow reactor in our pilot plant, which we continuously do a lot of trials, because as many of you may be aware, RT handles a lot of hazardous reactions like nitration, diazotization. These are not reactions that are easy to handle. So we do want to make inherently safer processes to begin with. And that is why a lot of focus on process safety also is required. I think one interesting also point again, Mr. Maulik highlighted is how do you disseminate the information across the company, and having multiple locations? How do you ensure that learnings from each location are translated across all the places? Because you want a chemical industry which is safer, so that the community is confident on the industry. So that's a very important part. So we have a very unique initiative that every day for half an hour, around 500 to 600 people of the company sit and discuss a topic on safety. And in most cases, the presentation is given by an executive or a shop floor operator. So it empowers them to be a part of the whole discussion process. So these are some of the key initiatives, because motivating people also is a part of the solution. So it cannot be only technical solutions that can work. How do you get them to implement? How do you ensure people are in sync with the overall strategy of the company? So these are the few initiatives that I would like to highlight, apart from the obvious targets that we have in terms of reduction of energy or reduction of water use, which are well documented, and I may not want to go there in much depth, but these are more of the software aspect initiatives that we have as a company. And I think the second question that you asked was regarding the opportunities in the green transition. As the biggest mega trend in the world right now is a transition to net zero. I think everybody would agree here. So I definitely see chemical industry playing a crucial role in this. The biofuel side, as Dr. Pramod also mentioned, is going to be critical. There will be other opportunities as well. I think lightweight polymers, because of the efficiency increase that they provide for vehicles, that will be a very big part of the future transition. And I definitely believe for chemical companies operating in that space can give good results. One more aspect that we are now finding out is on batteries. As the renewable portion of the grid increases, there will be definitely a big demand for utility scale storage. the current lithium-ion technologies will be difficult to deploy at a certain scale. So what are the other opportunities out there? So what we understand is flow chemistry is a very big opportunity possibly, and there can be a very big space for chemical industries and Indian chemical companies to also play a part. There can vanadium based chemistries or aluminum based chemistries or even organic flow chemistries are now picking up. So I definitely see that green transition is an opportunity for the chemical industry as a whole, and obviously a lot of these companies around here, I'm very happy to see that they are working in that sort of that direction as well. Thank you.
Thanks, Mirik. We are over with our first round. We have another 2 rounds, and I see around 15 questions being already posted. So I would request my speakers to be short and precise, and so I would request them to finish another 2 rounds in 2 minutes each. My second round of question to Mirik for you is, what are some of the climate change mitigation and adaptation measures that the chemical industry should take or look at?
I think climate change is going to affect us in ways that we can't sort of imagine right now. So one of the key things that biggest problem for the chemical industry I see is process heat. So how do you get steam in a fossil fuel free way? Because renewable electricity is already sort of cost competitive. But how do you ensure that you get steam in that way? So working in a way to mitigate that will be, I think, quite crucial. Bio-based fuels is a potential option. Then you can have carbon capture technologies, but they are nowhere near as mature as, say, wind and solar are for electricity. So I believe there are technologies on solar-based steam generation also. But again, these are early stage technologies. So this is going to be the biggest challenge for mitigation for the chemical industry. In terms of adaptation, just one point I would highlight is the severity of the storms that we faced this year are only going to increase. The frequency is only going to increase, and majority of the chemical industry is on the west coast. So that adapting to that, having your structures of the buildings that you make the plant from to having withstand the severity 5 storm, these are the small adaptation. As the temperature increases, maybe an 8-hour shift is not feasible. You may have to go for a 6-hour shift in the summer months. So how do you adapt to that? So I think things will take its own time, but it's earlier than we envisage. That is my sense. So again, I'll keep it brief at that.
Thanks, Mirik. But by listening to you, it doesn't seem that you are speaking for the first time in front of 360 odd people listening to you. And I hope you will have more such sessions with us, as well as other industry consortiums. So wishing you all the best.
Thank you.
Good to know that ICN was the first to capture you and bring to you so that we can know your views. And I think your views are very crystal clear with whatever that you are planning or whatever that you are strategizing in your company. Thank you, Mirik.
Thank you.
Now I request Dr. Pramod Kumbar, if you can talk about, sir, bioplastics, which you are planning to make from sugarcane bagasse. And you also talked about in your presentation also it's biodegradable. So in 2 minutes, if you can talk about that, sir.
Yes, thank you, Praveen. The bioplastics, as I said, people have a lot of misconceptions about bioplastics as such. When you talk about biodegradable, people think that every bioplastic that you make is a biodegradable, which is not true. There can be a renewable source, but not biodegradable, like polyethylene can be made from sugarcane to make ethanol, ethylene, and polyethylene. Braskem has one of the biggest plant of polyethylene, biopolyethylene, which is completely sold out now actually. So there is enough scope to do, they get premium on that. A lot of people have asked this question that whether these are going to be cost competitive. They may not, you have to pay some premium to green products. Not be very high, but there has to be some premium that is necessary to take this industry to forward. So in bioplastics area, we have started working on 2-3 platforms. One is of course the bio-butadiene, starting from 2,3-butanediol, which comes from the sugar fermentation. We have excellent fermentation technology to make 2,3-butanediol in very high yields, and then convert it to butadiene by single-step catalytic dehydration. So we can make on-purpose butadiene if you require at the source. So that's the technology that we are working on, which is not biodegradable, it's a renewable feedstock. On biodegradable plastics, we are working on polylactic acid and PHA. Currently, there is not a single plant in India to make polylactic acid. There are 3 producers of polylactic acids. One is, of course, NatureWorks, which is a 15-year-old plant. There is a Total Corbion plant and Corbion, these technologies. China is getting big way in polylactic acid because that is the only proven plastic which is biocompostable. It's not biodegradable, biocompostable. So PLA has very big scope, and we have started working on PLA starting from sugar feedstocks as such, waste feedstock from sugar, including 2G sugars. And other product we are working on is polyhydroxyalkanoates PHA, which is the only biodegradable plastics that is available today. It's coming on above upcoming plastics. The capacity is currently about 12,000 tons of PHA is made worldwide. One of the biggest companies, Danimer in USA, has recently announced a big plant for 100,000 tons of PHBV. So we are working on that platform using waste oils as feedstock, and we believe that this can be a cost competitive technology.
Thank you, sir, for your very elaborate thought question that I had asked. I think it will clear a lot of doubts that people do have. Now I come to Dr. Kamlesh Pai Fondekarji. Sir, would you talk about the green chemistry model 3R, which is reduce, reuse, and recycle, and how is it helping your company, Godrej Agrovet Limited?
Yeah. Prashant, in Godrej Agrovet, we really focus, our initial focus really initiates during the R&D stage. As when we start initiating the process development of any molecule, we start with the ideation process. And before we perform any experiment in the lab, we thoroughly debate and look at the sustainable practices. What is it really we would like to do? No? This is at a fundamental level when we do the ideation. When we want to go to the next step of the establishing proof of concept, we look at minimum use of a volatile organic solvent, something which we are looking at. Using a recyclable catalyst, focusing on the process which will give the minimum side products and the maximum yields. I think few of my other panelists also talked about it. So we would like to have the best possible yield, right? So, and we select the process, again, with a minimum number of steps and resulting in an energy efficient synthesis. This is also an important. So these are the criteria we look at before we even start taking up any development in the lab. To obtain the optimum yield and intrinsically safe process, very often we do need to use solvents. Substantially, sometimes it goes quantities which are fairly on the larger side, but it's extremely important that we judiciously follow the 3R principles. So first, we try to reduce minimum solvent as possible in our processes. Next option is definitely to reuse it back into the process so that we can recycle, reuse it again. And sometimes that's also not possible, but then we, because there are some impurities, when you recycle the process, there is a buildup of the impurities, there are some safety challenges, and therefore we do the recycle after appropriate treatment. And this is the key to the success of the process, because if you are not efficient here, your process can never be successful. Although water is green, right? But we cannot dispose of water which is contaminated. Therefore, the 3R principle also is extremely valid even when we use the water as a solvent. And good to tell you that all our chemical plants are basically zero liquid discharge plants. So we really strongly believe in this. And this is not only from the sustainability, it also has an economic advantage. Since if you want to really incinerate some waste, it's really expensive. And then it also results in the expensive products. So the purpose of the entire process is defeated. And therefore, I think the 3R is extremely important, and we strongly believe that's the key to the success of the process.
Thank you, sir. We will come back to you for the third track. Malik, if you're listening to me, how are you managing your waste management and recycling and energy and water conservation at Deepak Nitrite?
I think my camera has decided to stop working.
But we can hear you loud and clear.
Yeah, great, thank you. So on one hand, what we have done is Of course, you have all these government regulations and all which must be abided by. But even beyond that, what we have are, the assets that we have put on the ground have the relevant sensors associated and attached to them to be able to monitor the quality of the water that is coming in and the quality of the water that would otherwise be quote unquote disposed. In many cases, what we have done is we have put in low cost equipment that is able to recycle this and feed it into government approved processes within the plant itself. So the recycling of water, the recycling of steam that is used in equipment like ATFDs and MEs, etc., which over a period of time can just lose a certain amount of its pressure, but it is still extremely valuable to the to the rest of the process equipment. So ensuring that the right quality of steam goes to the right kind of process is another way to ensure that you are reducing what would otherwise be considered as an emission. And in all of this, ensuring that things like NOx and SOx abatement systems are there in place. Very often, a lot of chemical companies will say, okay, what you can't see that goes into the air, it's not necessarily pollution, right? Because nobody can see it, even though the effects of it will be felt over a period of time. So it's important for us to consider that it is not just what you can see and not see. It is also what needs to be assessed in terms of its medium and long-term impact on that environment. In many cases, what we have done is we have used different kinds of building material so that, as Nirik mentioned, ensuring that our equipment and our assets are able to withstand a lot more duress than they have historically been subjected to. Along with that, also ensuring that over a period of time, putting in the right kind of investment today allows you to significantly reduce future potential repairs and maintenance cost, erosion cost. A lot of chemical companies are situated in locations which are surrounded by other chemical companies. So you may not that way be able to control the kind of erosion that can take place from the air. So ensuring that the right kind of painting is done, and then it is repeated as and when you start to identify that there is a potential for corrosion. Basically, at the end of the day, any good chemical company will agree. Proactive, preventive measures are far more effective and more cost efficient than breakdown measures.
Thanks, Maulik. We will come back to you with the third part. Vinod Parimal, sir, if you can talk about how you're utilizing and monetizing bio-waste. So over to Vinod Parimal. If you can unmute yourself, Vinod.
Yeah, sure. So just to share with you, well, it's more about how we help others utilize bio-waste than ourselves, right? Like we provide technologies, right, and how we use them, or that was what I was trying to explain earlier about the compressed biogas, right? Our technology allows the use of bio-waste, say agricultural bio-waste, which, as you might have heard in many news reports, they are burnt. They cause significant amount of pollution, usually haze that covers Delhi, right? From time to time in the year. So this can all be utilized and monetized. So people who use this technology could monetize this waste rather than burn it, sell it for money. If they choose to do so, if this technology can be adapted by more let's say biogas plants, then they would have a natural outlet for this, without having to burn it. So that's one example of the use of bio-waste. Another is the use of industrial and municipal waste, right, of cities. Again, conversion from biomass to biogas allows these kind of waste to be used rather than moving it into landfills, right, as is frequently done. So you reduce that as well. So those are two examples I can just think of based on what we just spoke about.
Thank you, Vinodji. Now I come to Sunil Kumar ji, and if he can talk about the adhesive development process at Henkel India and with context to green chemistry and sustainability. So,
Sure. Thank you again for the question. So we have developed a comprehensive ADP process, which is basically adhesive development process. So at the innovation stage, we feel that it is better to catch the sustainability part. I mean, there has always been over a period of time, I think products always got developed, and many times it got developed in the past, if I could call it, saying that there is a customer, he gives an insight or a problem, and if basis that you go and you try to develop in your R&D center, then you come back, do multiple trials, and then get it successful for the product. And at that point in time, you have kind of taken this whole product development, keeping the customer insight in perspective. Yeah. Now, in the current scheme of things, what we have been doing is, the customer insight is definitely relevant. It is very much keeping the customer centricity, in perspective. But what we have done is that, when we are going to now develop a product, we are very clear saying that, we have the core team which starts looking at this at the, again at the ideation process. I think Dr. Kamlesh also talked about it, very similar, saying that, how do you, deal with these things at the ideation level? And we have also appointed a person. I mean, every project, has a core team, of course, of the product development side, and maybe the technical side, the business side, supply chain. All these things become part of your gate process of development. But most importantly, I want to highlight at Henkel, we also have the sustainability head. I mean, joining at right from the start. So this person, he or she, depending on wherever in the country, whichever part in the world, their main role is to ensure that what are the kind of, development products that we are talking about, whether it's right from the raw materials that we want to use in making this project, or what is the kind of, final output that we is going to leave as a residual waste, or can we recycle it? Is it possible to, bring it back? What is going to be the packaging that we are going to use, for these materials? At the end of the day, is those materials going to be, recycled, or can be reused, etc., etc. So, at the end of the day, what happens is, if it does not tick the sustainability, points, then the product cannot be launched or will not be launched. I think, that is the clear, thing that we have done. Now, at the same breath, let me also tell you that, there have been products which have been developed in the past. So it is important to sort of also qualify them and see that, how are they taking those sustainability parameters. So we have also in parallel put in, work streams at the country, region, global level, to really look into our entire product portfolio and see that, which are the ones, which are maybe having a negative impact, which got developed in the last, so many 100 years plus, and and how do we ensure that we bring them also back, to the positive level, or take a call in a short period of time to say that how do we phase them out to the next level of sustainable set of products. So that is how the entire process is there, and this is made very rigorous, very robust, so that we know that at some point in time, all the products that is getting developed or launched are 100% are very much sustainable products. Back to you, Praveen.
Thanks, Sunil ji. There is another. We are now close to the second track, and now we come to the third track. And the question is with respect to energy, water, and waste management done at Henkel India. These has been answered by most of our speakers. So if you have done anything different, otherwise my question to you would be, and I think it is for all, is that our topic is green chemistry and sustainability. So I request if you can talk about one challenge and one opportunity with respect to green chemistry and sustainability from India perspective. So over to Sri Sunil Kumar ji.
Let me again, maybe answer two questions here. One of them, let me start with first the opportunity. I think, see, the opportunity part of it I see today is fantastic, and let me tell you why I say this. When we go now to the customers, or anybody for that matter, our own partners or our logistics suppliers, whoever we are talking about, I mean, when we talk about green chemistry or sustainability, if I could call, the awareness level itself is very high, and also the interest to make a change, is also very high. To give some examples, again, in the area of opportunity, the number one thing I would like to say is, if you take our, I mean, the point to mention in adhesives is, it is everywhere. I mean, we are there as Henkel adhesives everywhere, but I mean, not really visible, and but very relevant. One of the recent ones which I have to talk about, keeping this challenge of health that all of us are seeing, we are, in smart, let us say, smart medical patches or medical, things that we are, very actively worked on. And this is, smart patches which are used. At the end of the day, the technology has moved where we are able to capture a real-time basis, the health of the person, and that is also sent to the cloud and gets captured about, how the whole, whether the heartbeat or temperature or whatever is the key, health parameters are captured. Yeah. And the most important part of it is, you need a very different kind of an adhesive chemistry here, which has, very, health and, people safety kept in, paramount at the end of the day to make it happen. And these are the kind of technologies we are talking about, I mean, at this point in time, where, it is making a very big difference. The second part of it, when you talk about a challenge, I think the challenge is more around, I mean, we may not, we should be open that there might be upfront investments, that we will have to responsibly, put as an organization at the end of the day. Each of these, whether we talk about whatever is the kind of, sustainability initiative, whether it is in the area of energy that we talked about, or solar or renewable energy or biogas, that we are working in our, factories at the end of the day, or the various, let's say, quality, I mean, accreditations that we want to do, right from whether it is ISO 5001, 45001, etc. These things take, I mean, time, energy, effort, money, and all, and a mindset change. I mean, and a huge commitment that we will have to do. And this is very important, that people should be able to see this as a, not as a challenge, saying that, do I need to commit for these things? On the contrary, should be thinking about saying that keeping more a longer time horizon in perspective, and the bigger picture of planet and industry and everything, commit for these things upfront, and that is going to be very important. So I would say the challenge is, how do you get the mindsets of everybody, oriented towards something which is sustainability focused, and that is the most important. And I'll leave a last comment here. At Henkel, we also have a program called at sustainability called Catch Them Young. I mean, we even go to the schools for that matter at, at a young level, whether people are 5th standard, 6th standard, it doesn't matter. And we start, really inculcating them with what is the sustainability in a very simple manner. So that, they are able to understand this, concept, not to waste water, or, how to sort of, manage, switch off a light and go. It might be simple things, but, it is important to inculcate a sustainability behavior right from the first, and that I would say is an important, culture that we should do as responsible.
Thanks, Sudhir Kumarji. Vinodji, if you can talk about one challenge and one opportunity, and I would request all our speakers to be short and precise, because we have already 10 minutes left and we have many questions to answer also. So one challenge and opportunity for green chemistry and sustainability.
So the challenge that we have is something that we have started work on, right? Which we need to develop further, right? In terms of scale up, So just a very short summary of what we're doing. Siemens and Evonik are, they're contributing their core competencies, like, so respectively electrolysis and biotechnology to artificial photosynthesis. The name of the project is Project Reticus. It's being done in the northwestern corner of Germany, right? So artificial photosynthesis, as you know, means combining chemical and biological steps so that energy can be used to produce chemicals from carbon dioxide and water. So this is a project that is ongoing right now. And that is, let's say, something that we look forward to developing further. That is the challenge. The opportunity, of course, I do not need to explain too much. I think what benefits can come out of this, right? Using carbon dioxide as a raw material to produce different types of chemistries is really, like, I think a great step forward if we can achieve a good economic scale up. So very short for you.
Maulik ji, if you can talk about one challenge and one opportunity, and in short about the future roadmap of your company with respect to green chemistry.
Yeah, one challenge for any chemical company, including Deepak, is not to take sustainability as just a buzzword. It's very easy to get emboldened and say, okay, what, sustainability is important. From an investor point of view, from a customer point of view, so let's invest in sustainability, because the problem with that is that sustainability will not be sustainable. So if you really want to be considering sustainability, you must think about sustainability as it pertains to productivity and profitability as well. They cannot be divergent. And therefore, I would personally say that a lot of Indian companies, unless they know how to do it, must refrain from, investing into technologies that are still in a very nascent phase. In other cases, what I would say that in terms of opportunity is that the Indian chemical industry actually has a very unique position in that not only is it growing, it also enjoys a really fantastic network effect. And with the growing consumption in the country as well, with focus on segments like water conservation, like clean energy from solar, from hydrogen nowadays that everybody is talking about. There's a lot of opportunity. The opportunity that comes to India should ideally be one that is mature, because we as a country are on one hand a lot more cost and productivity driven, but on the other hand, for India, money is not as cheap as it is in many other countries. So the Indian chemical industry must invest into technologies which are well proven and are able to be deployed at scale. If these two are not happening, I don't think that we should be investing just willy-nilly because it is a flavor of the season.
Thanks, Maulik ji. Now I would request Dr. Kamlesh Pai Phondekar, sir, if you can talk about one challenge and one opportunity with respect to green chemistry. If you can unmute yourself, sir.
Yes, sorry. Okay. Thanks, Prashant. I think in a Godrej Agrovet, we touch the farmer in all possible ways, right? So our verticals within our business includes, we are active in animal feed, we are active in aqua feed, we are in the milk, we are a chicken, we have a crop protection chemicals, which I talked about earlier, but also we are very much there in a oil palm. And we strongly believe the sustainability, and therefore our efforts are in the valorization of all the waste we generate. Yeah, I will just give you a classic example of oil palm. We are a very large producer of the crude oil palm. Yeah, and we extract basically crude palm oil from the fresh fruit bunches. This also means we generate a sludge, we generate a fiber, we have a shell, and we also have empty bunches which are a shredded fiber as a waste. So this is quite a waste to take care, right? What we try to do from the empty bunches of the shredded fiber, we have established a briquetting plant for a biomass. briquettes which are used for boiler, and boiler ash is then used in a cement industry. So we really have a good connect here. And then the concentrate derived from the treatment of the palm oil meal effluent, which is taken to the MEE, this is dried, and this dry powder is very rich in nutrient, and it is really good commercial value. Again, the condensate, what we recover, is used back in the process. And sludge is also transformed into the materials having a good commercial value, right? And all other palm oil biomass is a palm fiber and a palm nut shell, which is used as a boiler as a fuel. So we try to create value from the waste, and which is recognized by the various institutes, and we have received quite a few awards in the sustainability. For me, the challenge is how to make it better. Yeah. So today I'm creating the value. Is this the good enough value, or can we really still do better? Because I can see a lot of proteins in the part of the waste. So can I get that best out of it and use it for the better utilization? So that's the challenge for me.
Thanks, sir. Now I request Dr. Pramod Kumbhar, sir, if he can talk about one challenge and opportunity. Would request, sir, if you can be short and precise, sir, because we have to take a few questions also. Otherwise, they will feel disappointed, our delegates.
Sure. The biggest challenge for Praj, because we come from the mostly on the agri-processing industry, and one of the challenges is feedstock availability. Even though we are agriculture committee, the availability of biomass as a feedstock is a challenge because it's a low density feedstock. You have to aggregate that. So that's a big challenge for using biomass to convert to other technologies, as well as people said that still the bioplastics or biochemicals are not what we call competitive to the petrochemical or fossil fuel based chemicals and fuels. So that's a challenge, and we are getting closer to the creation of low cost technologies for that. Of course, it's the same opportunity, the plastic industry, because it's not biodegradable. People are looking at replacing the single use plastics, and I think if we can get to the cost point where people can give higher price but still affordable to use this biodegradable plastics, that's a big opportunity. In terms of biofuels, if you see, the government has brought the 20% blending instead of 2025 to 2023, and that's the biggest opportunity that we see in terms of making ethanol for blending, building these plants based on grain or sugarcane juice, all these things. So that is the biggest opportunity for Praj as a technology-driven company.
Thank you, sir. Now, Mirik, your last views, and then we open it up for Q&A.
Thank you. So I think I'll focus on two challenges, and a lot of the challenges have been already talked about. One interesting challenge that I foresee happening more in the future is actually accounting. So what happens in the chemical industry? You have multiple products. One product, for making one reaction, there might be in the end 3 products, say caustic, for example. You have hydrogen, chlorine, and caustic itself. So now, how do you allocate the carbon dioxide emission of that particular product? Do you allocate everything to caustic or hydrogen, chlorine? Why this is important is, as more and more customers start asking, and rightly so, that carbon labeling has to be done. There has to be a standardized practice across the industry, because if different matrices are chosen by different companies, suddenly there will be a mismatch in terms of what is actually being shown. So this is because it's relevant to us also as a company, because we have a lot of isomers. So if I have a particular isomer and a co-product being formed, how do I allocate my carbon footprint? And as transparency increases, and obviously everyone here also wants to do that, that will be an interesting challenge. And the second challenge that I would highlight is, as carbon capture picks up steam, usage is one aspect which will definitely happen. But if you just look at the numbers, usage is not going to fulfill all your carbon capture, because the carbon capture requirement is going to be much, much higher. Then does India have suitable carbon storage in terms of geographical location, like deep saline aquifers? Do we have that? I, to my limited knowledge, do not have any idea whether the government has done any sort of work on that. But I believe that is an important step to be figured out. Do we have such geographical assets that we can use for carbon dioxide storage? So just my 2 challenges I'll highlight. Thank you.
Thanks, Mirik. Now we open it up for Q&A. We have around 37 questions, which I see in the Q&A chat window, and all our speakers can also have a look at it. The first is Camtel. It says, wish to know if companies in India are re-employing their industrial waste into use after refining same. Vinod, if you can answer this first question, Vinod Parimal.
Yes, at least we try to support this, and we try to support also. Let's say one example that we work on currently in our R&D is how to recycle PET. Right? Let's say we have a lot of virgin PET production, but we try to look at how chemical recycling is possible, trying to provide, let's say, additives for the methanolysis reaction that could possibly deliver a economically efficient chemical recycling route, right? And that's something that we try to contribute here. The R&D is actually going to happen here in India and not somewhere else. So we know that India is a very large PET producer and consumer, and typically right now what is done is mechanical recycling. So that's how we would I would say as in one example that we contribute.
Vinod, I'm giving you another question to answer before you leave. Yeah. This is from Ruchi Bhatia, and she talks about how the concept of industrial symbiosis can be so that waste for one can be a raw material for the other. So how are you doing it globally? Because that can be a good example to learn from. Or if you're doing it in India, if you can talk about that briefly.
Yeah, just very briefly, I can talk to you about the green hydrogen topic, right? This is connected to the reticus, let's say, a reaction that we try to undertake, right, where you produce viable chemicals from carbon dioxide and water. During this process, there is the production of hydrogen, right? And green hydrogen, then that is actually produced from water by electrolysis, right, using electricity generated from renewable resources. So this is something that we try to use, and once we develop the green hydrogen further in terms of let's say an economically efficient process, this is something where we see some benefit for the industry.
Thanks, Vinodji, for giving quick answers. We have Mr. Ratnakar Deshpande. He's talking about will the well-being of our planet take over economics, viability, and make green technology options mandatory at some point of time. Kamlesh Pai Pondekar, Dr. Kamleshji, you have talked about the economics part of it, so if you can answer this briefly, sir.
Prashant, could you please repeat the question?
He's talking about the well-being of our planet take over economics viability and make green technology options mandatory at some point of time. He's talking about how economical are these so that green technologies can be deployed. You briefly mentioned about it.
Absolutely. Yeah, I think the innovation is a key part for all this. I talked about the classic examples of flow chemistry. When we get into flow chemistry, we have an atom economy, we reduce the waste, we have intrinsically safe processes. We need to get more and more into this and how to make this commercialized. So only the chemistry is not sufficient here. A lot of chemical engineering come into the picture. So the whole entire situation need to come, to make this economically viable. So these processes will not be only green, but also economically viable process. And they have a good opportunity to bring, beat the classical processes which are batch processes. So I strongly believe in that, and I am very optimistic about it.
Thank you, sir. Kalpatru State is talking about, it's just a feedback. It is heartening to hear industry leaders talking about high focus on sustainability at large, especially the progress being made by most of the leaders hearing. Just a comment. Ranjit Wag talks about, is there any membrane or other technology available by which we can able to separate carbon dioxide from our other process stream? I think Vinod Parimal ji talked about these membrane technologies for green separation techniques. Presently, he is not here. So, but he has already talked in his presentation. Then Kalpatru State is again talking about that ESG sports are getting traction in eyes of investors and shareholders, as well as hence cost of capital and market cap are getting directly linked to it. Then how far we see Indian players adopting the ESG index so as to be more objective and have quick reference on benchmarking at global levels for being sustainable and also competitive along with profitability. Maulik, you talked about what we can say that this should not be the buzzwords, sustainability. Then this question is related to that.
Yeah, although that said, I did not understand what the question is. I heard, But I agree. I think India and Indian companies have a good ways to go before they are as quote unquote sustainable, or before they take this as seriously as a lot of Western companies. But we're on the path, right? And a lot of Western countries and companies realize that you cannot hold everybody in the world to the same standard and accountable at the same level. And therefore, there is a clear understanding that companies that are expecting this from the suppliers in countries like India, they need to have what Indian companies need to show is intention and a timetable between now and the point at which they are going to be able to achieve certain set targets. Those targets are then monitored in a systematic fashion. And I think that's the right approach. Expecting everybody in the world, regardless of their starting point, to end up at the same finish line at the same time is unreasonable. And I think that this kind of a collaborative approach is certainly going to help Indian companies realign in such a way that it does not significantly impact their competitiveness.
Thank you, Maulikji. Kalpatru Estate now has revealed his name. It is Sandeep Arora from Grasim Chemicals. Okay. Mr. Pandurang Landge, he is talking about, is it not that some of the gray chemicals are low priced due to feedstock and advantages, and less spends on environment protection is leading to green chemical products? In reality, the world has to realize this and be prepared to pay high price for green products. So let me ask Dr. Pramod Khumbar, our R&D people, whether green will lead to high prices, sir.
So green chemicals need not be very high prices. There will be certain premium that will be required to make it sustainable, but it's not going to be 2x or anything, maybe around 20 to 30% higher. And the technologies are improving a lot, like synthetic biology. If you look at the current synthetic biology that has been practiced or that is being evolved, you can make all the microbes produce much higher quantities of the chemicals during fermentation. The chemicals that you are like, if you see the recent announcement by Covestro, you can even make aniline by fermentation. Nobody would have thought that you can make aniline by fermentation from sugars. So these are the things that are happening because of the synthetic biology. And I believe that in long term, these technologies will match, will be little higher than fossil fuel based processes, but they will be pretty close as you build on the scale and everything.
So one question is also, is the Sepuran green compatible in all types of chemical manufacturing sites, and what are the areas where it is not compatible? Is it related to you, sir? Mr. Ramkrishnan Subramaniam is talking about it.
What is it? I didn't get the question.
Sepuran green, Sepuran, SEPURAN, green compatible in all types of chemical manufacturing sites, and what are the areas where it is not compatible?
No, I have not heard about this Sepuran, so I don't know.
Kamlesh,
sorry, I'm not also familiar with this. Yeah.
We will give it a miss. Mr. Sanjay Dodia talks about how chemical industry will enhance R&D in absence of lacking consortium and open innovation platforms between industry and academia. Shortly, sir, Dr. Kamlesh.
Yeah, I think it is a key part. Industry academia collaboration is the most important part, which we strongly believe, and in Godrej we definitely do that, because the key is we cannot do everything. We don't have a bandwidth. Neither we have a competency to do everything together. So it's important to focus on the technologies which you are best at, and collaborate with the academia, where you get a lot of knowledge from them. You get a lot of learnings. We have done it in the past. We have been very successful, and we continue to do that. So at any given time, we have a really lot of successful collaboration. But this collaboration needs to really increase across all the industries. Yeah, this is today very few selective industries does that. But no, what I believe is it will come across, and this will be really a good bet to move forward. And that's the key part for the innovation.
Another question is from Kamal Dhareva. How does the chemical industry monitors its circular economy strategy and implementation? Miri, could you like to answer this?
Yeah, I think so. There are a lot of aspects to circular economy, right? So you have to narrow the loops where you have to increase the efficiencies. Then the loop has to be completed. So I think how we look at it is narrowing the loop is terms of increasing the efficiency is a very obvious thing to do, and the recyclability of wherever is possible. So if you have a ZLD, then what do you do with the water? Can you recycle it? So the question should be broken down into relevant pieces, and then in each case what we do is monitor that separately, because it's not like you can be a circular company suddenly. Some are slightly longer term initiatives also, that can we get feedstock from a circular basis, because now this can be a big game changer, because we are a big consumers of aromatics. And as I think Dr. Pramod also mentioned, people are thinking of making aniline. So now there are from fermentation or bio-based or plastic-based, feedstock-based bioaromatics are also in the pipeline. So this can be a longer-term target to complete the loop. So I see monitoring in terms of what can be the future and what can be the present. That's how we are currently looking at it at RP.
And one question is, any emerging technologies to recycle cooling tower blowdown as makeup cooling tower or cooling water dosing chemicals, then minimize the blowdown itself?
So I think, should I take that? As in, I just have, so one thing is, one of the things from a water conservation point of view, we are looking at in locations where air cooling is possible. So use that. So basically you take out the water in terms of a water conservation point of view. There are some interesting technologies where you can actually use the cooling tower process to actually capture carbon itself. So there are a few companies working on that. I am not aware in much technical details about how this works, but these are the two examples that I could just think of offhand.
One question was with respect to what is the status of high temperature lift heat pumps in India. So Kamleshi, if you like to take.
Sorry, Praveen, I will not be able to. Yeah, sorry for that.
Pramod sir?
No. I don't think so. I will be able to answer this also.
The question is with respect to status of solar dome desalination technology in India. He's talking about use of solar. We have seen in few rivers, they have used this dome technology. So
I think this is the technology on which the city in Saudi Arabia is being made, where they are planning to use this solar dome to actually generate desalinate water. But I believe that project is also a long time away. It's a very immature technology, so as to say. It's being developed by a UK-based company, but I think it's still a long ways away in terms of India, as per my limited knowledge.
Do you see any feasible future of hydrogen fuel as a clean source in the industry? What we are seeing is we have a complete e-conference that we did on hydrogen. That recorded version is on our website. Please go and listen to that audio and video, and you will get all the answers related to hydrogen about feasible future. If just adding to what yesterday Reliance made a very big announcement of what we can say clean energy, and they are making an investment of 75,000 odd crores, almost $10 billion, and there they are talking about both fuel cell as well as electrolysis technology, and trying to develop this indigenously so that it can be exported as well as used in the Indian context. Manoj Kumar ji, this I will take the last question. We are already reaching 4:45. Can we look into the elimination of various types of solvents usage in the reactions? Because to separate the solvents again from the reaction mass for reusage consumes very high amount of energy. And most of the cases, distillation is used for the separation, which is the highest energy consumed method. So I request both our R&D heads, Dr. Kamleshi and Dr. Pramod, if you can add to this.
Yeah. So, okay, if I start with, this is the ideal situation, right? So we don't want any solvent and we want to get into that direction. But in reality, it's a challenge, right? So ideally, no, we have to get into the, as I said, with the 3R principle is a key part here. First, try to minimize it, but you want to get the best yield, you want the best atom economy, you don't want any impurity formation. If it doesn't work, then try to recycle it if there is no impurity and it doesn't affect the safety of the process. If not, then that's the final is a recycle. But I'm afraid if no, you have to choose the minimum amount of solvent what you would like to really get in, but there is no really thumb rule as such today what is the best. right? So it's a lot more of a particular process for particular step, and you need to look at it. That's my opinion.
Dr. Pramod, sir?
Yeah, I think I agree with Kamlesh. It's the organic chemistry itself needs some solvent sometimes. It's not that every time you can't completely avoid the use of solvent. There will be use of solvent, but we have to look at what are the alternatives in terms of green solvents. We are working on a process to make ethyl lactate, which is a green solvent, which is upcoming solvent. So we have to look at alternatives which are greener solvents than you currently use. Try to avoid as much as fluorinated solvent is a big no-no. So you have to see what are the alternatives for that. But it's very difficult to say that it is process dependent. You can't lose your atom economy because of you are not using solvents. So you have to look at everything holistically, how you design the process.
Birik, one last question before we wind up is from Dr. Satya Prakash Goswami. Would you like to implement green chemistry-based QA, QC, and research for our Aarti industries?
I'll have to understand it better. Maybe they can contact me and try to, if that's feasible. Because yeah, it looks interesting, but I don't know the details on how that's at QA and QC.
So we have this a whole host of questions, and I see now it is 46. We will not be able to take up the whole set of questions, but definitely during the course of the time, we will try to answer as many as possible. Let me thank all the speakers who took time out and be present for this conference and gave a lot of support in terms of sharing their knowledge and also answering all our queries. We had Mr. S. Sunil Kumar, President Henkel India. We had Maulik Mehta, CEO and Executive Director Deepak Nitrile. Mr. Mirikar Gogri, Head Corporate Strategy, RC Industries. Dr. Pramod Kumbar, President and CTO, Praj Industries Limited. Dr. Kamlesh Pai Pondekar, Head Research and Development, Godrej Ogrevoit Limited. And Mr. Vinod Parimal, Regional President of the Indian Subcontinent, Evonik. So a big thanks from ICN, Indian Chemical News, as well as from all the delegates. I would like to thank our speakers for taking time out from the busy schedule to be present in this e-conference to give their views and also answer all our delegate queries. I request all delegates, this is the normal process that we do. We also take feedback. So I would request all delegates, around 185 of them who are still present, if you can rank this e-conference on the chat window, 1 being the lowest and 5 being the highest. So please rank for this e-conference so that we can work on it and try to improve on it. If you have any suggestions to make, please also write. I think 5-4 is what we are getting. So we are closer to say 80 to 100% between 90 around. We will try to improve further as we move forward. And as Mr. Sunil Kumar talked about, catch people young. So we will always try to have a mix of young as well as experienced hands so that we can get a complete 360-degree view of what's happening in the industry. I would request all delegates to register for the next set of events that we do have. And as then we announce these events, we put it on our website in the e-conference session or the conference session. On July 23, we have on the draft PCPI policy, making India a petrochem manufacturing hub. On August 6, we have on agrochemicals, which is doubling the market size by expanding horizon by 2026. Let me thank all delegates who participated in this event. Those who registered but did not participate can watch the recorded version from tomorrow onwards. Let me finally thank all the speakers, delegate, and my ICN team members for making this e-conference a great success. This is Praveen Prashant signing off to meet again on July 23rd, 2021 at 2:55 p.m. Indian Standard Time. Goodbye and namaste. Till then, stay safe and take care.